Okay, so we're going to do some extra practice for real numbers, section 1.3. We're going to practice first classifying numbers. I would like to zoom in a little bit. There we go. So the first thing we're going to discuss is which subsets these numbers fall into. Negative pi is a real number, so we're going to use the big R for real numbers. And then we ask ourselves, is it rational or irrational? Because it has to fall into one of those two categories. Rational numbers are numbers that can be written as fractions. Irrational numbers are non-repeating, non-terminating decimals. And of course, pi is an irrational number. So we're going to classify that as irrational. There are no subsets under irrational. So once you've classified a number as irrational, then there are no smaller subsets to classify into. So let's look at negative 10. Negative 10 is a real number. Is it rational or irrational? Well, it can be written as a fraction, so this is rational. Underneath rational, we ask ourselves, is it an integer? Can it be a tick mark on a number line? And it is, so we'll call it an integer. Under the integers is the whole numbers, which are a set that starts at 0 and goes on infinitely in the positive direction. So since this is a negative number, it's not a whole number. So if it's not a whole number, it can't be a natural number. So that's it for negative 10. Negative 9 over 2 is a real number. Is it rational or irrational? Well, since it's a fraction, we know it must be a rational number. Is it an integer? Would this be a tick mark on the number line? And the answer to that is no. We would not use that fraction as a tick mark on our number line. So we're done. 23.458976975. Nice number. Is this a real number? It is. Is it a rational or an irrational? Well, since this number has all these decimals that go on forever, we know it's non-terminating, and they are not repeating the same pattern. So this is a non-terminating, non-repeating decimal. So this is an irrational. And under irrational, there are no smaller subsets. So we're done. 0 is a real number. It is a rational number. We could write it in a whole bunch of different forms as a fraction. Is it an integer? Would it be one of the tick marks on our number line? Yes, it is. It's an integer. Is it a whole number? The set of whole numbers actually starts at 0, so 0 is part of the whole numbers. So it is a whole number. Is it a natural number? Well, the only difference between the whole numbers and the natural numbers is the absence of the 0 in the natural numbers, so 0 is not a natural number, so that would be it. The square root of 9 actually can be simplified. I know we haven't talked about square roots yet, but the square root of 9 is equal to 3. And we'll talk about square roots in chapter 6, but that's what it is. It is a real number. It is a rational number. We could write it as a fraction. It is an integer. It would be a tick mark on the number line. It is a whole number, which go to the positive, and it is a natural number. It is part of our counting numbers. So that would be classifying. The next section says create a number line and graph the following on the number line. So let's see where we can create this number line here. Let's make the number line black. Nice and straight. So this is 0. Put some tick marks on here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so the first number we're going to graph on our number line is 4. 1, 2, 3, 4. We'll label this as 4, and we'll put a dot there. Okay, the next number we're going to graph is 0, which is already labeled, so that would be right there, 0. Negative 1 is right here, and we'll label that as negative 1. Negative 5.5. Okay, so we have negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Negative 5.5 is someplace here in the middle of negative 5 and negative 6. So we'll graph that right there, and we'll mark it as negative 5.5. Negative 9/4. Well, it's kind of hard to graph an improper fraction, so we should convert it to a mixed number. So let's see, 9/4 is equal to, okay, remember to divide. 9 divided by 4 is 2 with 1 left over. So this is 2 1/4. So we'll look for 2 1/4 here. So this is 1, this is 2, this is 3. So 2 1/4 is about a fourth of the way between 2 and 3. This is hard on this tablet to do this. There it is, right there. And we'll label it as 2 1/4. Okay, -2.75. That's -1, -2, -3, -2.75 is 3/4 of the way between -2 and -3. So we'll mark it off right here. -2.75. And pi. Well, do we remember that pi is approximately 3.14? So where is 3? 1, 2, 3. 3.14 is going to be just a smidge past 3. So right about there. So this would be pi. Yes, pi. I'm going to label it up there like that. So I think that takes care of our number line. Yes. All right, down here we're going to do greater than, less than, or equal. Here, I'm going to do this straight. Okay, this is the less than, this is the greater than, and of course we know the equal sign. All right, we're going to compare -17 to -18. The greater one will be the one further to the right, which will be -17. So we put our symbol in here like this. The open part goes to the greater, the pointy part goes to the one that's less, and we read this as -17 is greater than -18. 3.001, 3.01. This one has 3 decimals, but this one only has 2. So to compare them, we'll add an extra 0 over here so they have the same number of decimal places. Then you can see this looks like 0.00001, and this is 0.10. So this looks like a 10, and this is a 1. So this one is greater. And again, the open side to the greater, the pointy side to the one that's less. And I just did that backwards. I can't erase. Trying to get the eraser to work, but it's not working, so I guess we're going to cross that out just like that if my eraser's not working. I said this one is larger, which it is. It looks like a 10 on the end. This one looks like a 1. So this is definitely larger, and then I wrote the wrong sign. So the open side to the larger, the pointy side to the smaller. Cannot get the eraser to work. Okay, so let's look at the next one. -8/3 compared to -9/3. And I said before in the lesson that when the denominators are the same, it's very easy to compare fractions because you can ignore the denominators then and just look at the numerators. And of course, these are both negative. So we're comparing -8 to -9, and which one is further to the right? And that would be the -8. So -8/3 is greater than -9/3. Let's compare. These are the absolute value bars we talked about in the lesson. How far is this number from 0? So we're going to simplify it first. -6 is 6 units from 0. So this simplifies to make a 6. A +6, this is also an absolute value here. These are the bars. It looks like 161, but it's not. These are absolute value bars. This is saying how far is 6 from 0. So this is also 6 units from 0. So these are equal because they both simplify to make 6. All right, these are not absolute values. These are parentheses. So what we're being asked here is the opposite of -2. The opposite of -2 is +2. Over here, just the opposite of +2, which is -2. So we're comparing 2, +2, to -2. And +2 is larger, so the symbol goes this way. We read it as 2 is greater than -2. So here's more absolute values for us. We have to remember that they don't cancel across absolute value bars like they did up here across parentheses. So first we do absolute value, then this negative tacks on at the end. So the absolute value of -23 is 23, and then the negative sign goes with it, and that's coming from here. That negative sign goes on with it. Same thing we're going to do here. The absolute value of 23 is 23, and then that negative sign comes with it into the front. This negative sign going right there. So we're comparing -23 with -23, which are equal. So what do we have here? We have the opposite of the absolute value of -5. And again, the absolute value of -5 is 5, that front negative sign going with it. Over on this other side, the opposite of the absolute value of 5. The absolute value of 5 is 5, and that negative sign going on in with it. So these are equal. All right. Here we have absolute value of 4/5, which is just 4/5. How far is it from 0? And here we have the opposite of -7/10. Again, these are parentheses, not absolute values. So in this example, these two negatives will cancel, and we get 7/10. Now, to compare these fractions, the denominators have to be equal. And right now they're not. But we can change fifths into tenths. The common denominator for 5 and 10 is 10. So we can change this to tenths. How do we do that? Remember, multiply on the bottom. 5 times 2 equals 10. So on the top, 4 times 2 equals 8. So we're comparing 8/10 with 7/10. And of course, we only need to look at the numerators. So compare 8 to 7, and 8/10 is greater. Okay, down here at the bottom, parentheses again, not absolute values. So this is just -0.003. Here we have absolute values. So the absolute value of this number inside is 0.004, and the negative sign is going to carry down with it. So now we're comparing two negative numbers. They both have 3 decimals. So it looks like you might be tempted to say that this one is larger because it's a 4 instead of a 3, but remember that when they're negative, they go in the opposite direction. So you're looking for the one that's further to the right, which would be this one. So -0.003 is greater. All right, down here at the bottom, we have some practice for union and intersection. So now we have a set A being 1, 5, 10, 20. Set B is 5, 10, 15, 20. This says find A union B. Remember, the one that looks like a U is a union. And union is just putting two things together. So we're going to include all the elements in A and B. I'm going to start with 1, 5, 10, 15, 20. And when we do a union, we have to check to make sure that all of the elements of each set get in. And they did. So there's our union. This one says A, and there's the symbol for intersection B. So this is asking us what do they have in common. So we're looking for which elements appear in both sets. And it looks like the one is in A, but it's not in B. The 5 is the first element that we see in both sets. So 5 is part of the intersection. The 10 we see in both sets. So 10 is part of the intersection. And the 20 we see in both sets. So 20 is also part of the intersection.